Hello, and thank you for watching. I'm going to show everyone basically exactly what a hacker does. We call this a penetration test, or a pen test for short. We also like to refer to this as a anti-hacker test. To get started, I'm going to quickly go over the network layout, the topology, so everyone can kind of understand from a high-level overview of what we're going to do and how this is set up. So for our demo, I have created virtual machines. This allows us to really test multiple operating systems very efficiently and effectively, all within the same environment, but segregated. So I'm going to go over that right now. The first document we have opened up here is our network map overview. As you can see, the blue systems down here symbolizes the healthy, clean network. This would typically be your home or business environment. As you can see, all the systems are protected and connecting through a firewall, labeled here as a home business firewall. The environment has smartphones, Windows 7 devices, Windows Server 2008, Windows XP, and tablets, and there's other devices as well behind this firewall. Today we're going to focus mainly on the Windows 7, Windows XP, and Windows Server 2008 systems. However, smartphones and tablets, along with other systems, are also attack vectors and attack points. From the firewall, they then connect up to the internet. Now, out on the internet, we have labeled here the hacker's firewall, and behind the hacker's firewall is the hacker system and the hacker server. And to basically illustrate, this is the goal for our presentation. The green dotted lines indicates the network traffic flow of basically how the attacker will be going through the internet and compromising a particular system. In this particular case, since Windows XP is going away, and there are numerous vulnerabilities and exploits and weaknesses found in XP, this demonstration shows how when one XP system gets compromised, or any system get compromised, how it can then easily connect and infect all of the other network devices. This type of diagram here shows what's known as a pivot attack, which is a type of attack vector. So with that said, I'm going to go ahead and close out these diagrams here and show you the rundown of the environment. So this is the Windows 7 system here. This is the Windows Server 2008 system. This is our Windows XP system. And the hacker system is running on Kali Linux, which is a former operating system based off of Backtrack. This is the newer version of it, which it's all a variation of Debian Linux. This is the operating system that hackers typically use to launch their attacks. It has many built-in attacking tools and exploration tools to help aid in what they're trying to do. At the same time, security professionals like myself can also leverage this to be able to test the environment. So there are multiple attack vectors that can be used to compromise a particular system. We're not going to go over all of the attack vectors right now because there's way too many of them. But I've already have crafted a malicious payload, malware, a Trojan, backdoor, call it what you will. And what this particular piece of software does is it tunnels a encrypted connection back to the Kali Linux system, and it does that through a HTTPS SSL using AES encryption. And basically what all that means is this payload can bypass pretty much all security standards that are typically implemented, such as antivirus, anti-spyware, anti-malware, intrusion detection systems, security information event monitoring. Nothing can break into this tunnel because it's all encrypted, and therefore our activities are able to go unnoticed or undetected. So to skip ahead, basically I've gone ahead and just placed this piece of software on the system. Now there's multiple ways one could get this software on the system, whether it's through an email attachment, through a website download, whether it's an infected USB stick, or in some cases with businesses, a bring your own device, and basically a infected device could spread the malware that way. So to save us time and to skip ahead, I've gone ahead and just implemented this piece of software on the system already. Now we will make another video demonstrating and enumerating each type of attack vector, but to get us started here, I'm going to go ahead and just simply double click on it, and you'll see things start to happen here on the attacker side. Now notice on the server side there, when I clicked on it, nothing really happened. There's no pop-ups, there's no warnings, nothing's flashing or going crazy on the screen. I encoded this on purpose to be that way, so it's very stealth. And what's happening here is this is known as what's called a botnet, going back to a command and control center. This is a command and control center. It is running what's called interpreter. And so from here, you get a graphical interface. The attacker gets a graphical interface of the particular system, and so we can quickly see the host name, what user executed it, the IP address, and then we can see the firewall that is coming through and how we're getting connected here. So we're going to go ahead and get started here real quick. So the first command we're going to issue is sessions-i1. And what that's going to do is going to get us connected into the interpreter shell, into the system. At this point, there's all kinds of things that we can do. So the very first thing I'm going to show you that we have the capability of is setting up what's called a pivot attack. And what a pivot attack allows us to do is essentially set up the capability for us to add a network route entry to allow us to now send commands through this system to find and locate other systems on this on this system's same network. So we're going to do what's called an ARP scan, and an ARP scan happens really fast, and it's going to be able to identify other systems on the network. So as you can see, it's already finding other systems. I'll go ahead and scroll down here, and you can see that. I'll actually zoom out just a little bit. So put it in perspective there. As it finds more systems, they're going to keep popping up in this list here, and then it will give you a guesstimate of what it believes a device is. These are all virtual machines, so it did a very good job of enumerating it's a VMware device. It also noticed that I have a Cisco/Linksys router in the mix as well, and it's still scanning. Now, what we're going to do to be able to get a little bit more information on these systems, we have to set up a scan that will actually go out and really do an in-depth scan of each one of these devices. So the way we do that is we right-click on each one of these systems here and basically do what's called a scan. And it's going to do a scan that's going to go out and locate open ports, open services, and really try to figure out what it is that we're dealing with here. So I went ahead and initiated 5 in-depth scans. While the ARP scan's still going, I believe the ARP scan just finished because I see that there's a system with 255 on it. Anyways, once this completes, we will have some more information. So I'm going to go ahead and pause the video here until it's done, and I'll come back with the results. Alright, I've gone ahead and started the recording back up again. As you can see, the scan has completed on at least the last 2 systems here. Notice how the screens now show a Windows logo. Both are a little bit different. I'm going to explain this to you real quick. Every system that we can control that's been compromised, the actual screen here turns red with like the lightning bolts. The systems that are gray are just normal systems that we do not yet have control. So right now we're going to go ahead and show you a few things that hackers have the capability to do from a compromised system. So the very first thing I'm going to show you here is basically what's known as a keylogger. And a keylogger is what hackers use to help steal passwords, usernames, and other things that an end user might be typing. So this is a script we're going to run. It's called run keylogger, and as you can see, it is going to go ahead and start the sniffer. It's called. So I'm going to go ahead and head back over to our Windows server. I've opened up a text document here just to demo this for a quick test. So this is a test, comma, do you see it? Enter Nick. Okay, we got some text there. Now again, that could have been typing in a website address, a password, a username, whatever. Now what we're going to do is we're actually going to take a look at that file. So we're going to go ahead and open up another command prompt window here real quick so we can browse to that file location here. And we're going to use a feature called cat, which is built into Linux to view text information. Alright, so looks like I forgot to migrate my tunnel into explorer.exe. Explorer would have captured everything. As you can see, it's kind of broken. TIIA text, do you see T, return Nick. So as you can see, it did miss some characters. However, there is better ways to do that. So that was just a quick example of how a keylogger can work. And to migrate, which is basically moving out of the process that we're running in, we first want to see what process the Explorer.exe is running. So we can see it's running right here on 3060. So we're going to type this. It's going to be migrate 3060. And what that's doing is it's switching our process that we're using, our encrypted tunnel, into Explorer. So in the unlikely event that someone actually sees something running and tries to cancel it, if they were to cancel Explorer, the whole system would stop. The start menu would go away, all the icons would go away. So we're going to do a test here. We're going to get UID. So this is going to show us who we're running as. So we're running as administrator currently. Get system. We're going to try to escalate our user account from the administrator now into the system account. And it says we got it. So if we say get UID, you'll now see that we're using the system parameters. So now if we were to re-execute that keylogger, we'd have a better chance of capturing all the keys. Another feature that can be used to attack a compromised system is to basically dump the hashes. And a hash basically is what a password is stored locally on. It takes the clear text information and basically hides it in an encrypted hashed value, so it doesn't look like it's a readable content at all. So the way we do that is we're going to go ahead and come in here to dump hashes, and there's two ways I like to dump the hashes. The first one is right from the registry, so I'm going to go ahead and launch that, and then while it's obtaining the hashes of the user accounts. Alright, join me in the next video session where I show you how we actually crack these hashes. So this is part 1. Look for part 2 coming up next. Thank you for watching.